In this video, we will find the zeros or roots of this polynomial. We will get some help from our trusty TI-30XS multiview. Hit the table button, clear out whatever you got in there, and type in this polynomial. So I have 3x to the third power plus 7x squared plus 5x plus 1. Before I hit enter and such, let me remind you of the fundamental theorem of algebra. The degree of the polynomial is going to tell us how many roots or zeros there should be. Now there might be repeated roots. So for example right here, all of these choices mention that -1 is a root. But then they have this mult. Mult stands for multiplicity. Alright, a multiplicity of 2 means that -1 actually will occur twice. It's counting as 2 of the roots. So if I factored it, that would mean I would have x plus 1 times x plus 1. Okay, making up this polynomial. So understanding that some roots might be repeated, if you count this twice, if you count this as 2 roots, then if you add up all the zeros, there should be 3 of them. That includes any imaginary roots that we ever find. So I'm going to hit enter. I like to start at -10. I'm going to scroll down looking for 0 on the y side. Now because of the multiple choice answers, I notice that -1 is included on all of them. So I already know that I'm going to find a 0 when I get to -1. But I'm going to just pretend that I didn't know that. Oh look! There's a 0 at -1. That tells me that -1 is definitely a 0. Once I find a 0, I can use it to factor the polynomial by doing synthetic division. So here are my coefficients: 3, 7, 5, and 1. If I bring down that 3 times -1 is -3. That's 4 when you add these up. 4 times -1 is -4. Add these, that's 1. 1 times -1 is -1. Add them up, you get 0 as you should. Now, if I turn this back into a trinomial, this must be 3x squared plus 4x plus 1. Okay, this 0 or root of -1 would come from a factor of x plus 1. So far I have factored the original polynomial down to this. Now I'm betting that we can factor this trinomial further. So let's go ahead and do that. Okay, this trinomial will surely factor as a binomial times a binomial. So 3x squared can only factor as 3x times x. Mercifully, 1 can only factor as 1 times 1, so this is going to be pretty easy. Inner plus outer must equal middle. Inner, I have 1x. Outer, I have 3x. I'm trying to get a middle of 4x, and of course I just need to let them be positive, and that will make the 4x. So once again, bringing down my x plus 1, now I have factored the polynomial down to these 3 factors. So we are looking for zeros, not factors this time. Alright, we're finding the zeros of this polynomial. So what I would do is set each of these equal to 0. Okay, so just drawing these lines here. So I've got x plus 1 equals 0, 3x plus 1 equals 0, and x plus 1 equals 0. Well, we already knew that this would give us negative 1, and you see that it is repeated twice. So that is negative 1 multiplicity 2. Okay, so right there it tells us that it's either A, B, or D, because I've got negative 1 multiplicity 2 because of the way it's repeated twice. But now this other 0 is going to come from this factor. If I subtract 1 from both sides, I have 3x equals negative 1. If I divide both sides by 3, I have x equals negative 1/3. So I have negative 1 twice, and then I have negative 1/3. So that's negative 1 multiplicity 2 and negative 1/3. So the answer is A.